Hi, I'm Matt Mulvaney from Explorer, and this presentation is called Apex Version Control and Team Working. So who are Explorer? Explorer are Oracle Platinum Partner. We are multiple award winners, including back-to-back UK OUG Database Partner of the Year award winner. We've got dedicated Oracle teams. We're a UK team of Oracle experts, and we have Oracle Engineered System Practice, and we're celebrating over 20 years in business. These are our services. I'll just leave this slide up for a moment. So more about who I am. I'm Matt Mulvaney. I've got many years working in Oracle technologies, which includes Oracle Forms, reports, and most recently, over the last few years, actively within Oracle Apex, and we work across all business sectors. So my main responsibilities are being a trainer, speaker, a blogger, a consultant, and ultimately a developer. And I take these above opportunities to promote and enthuse about Oracle Apex. So before I begin, this subject is very broad. There's lots of opinions and views about this subject. So what this presentation aims to do is take the best from lots of different perspectives, what different businesses are using. Apex works with lots of different businesses, and we want to present some of the best findings that I've investigated and researched. And before I begin, this presentation covers a lot about version control and including Git. I just want to say before the presentation begins that I'm not a Git expert, although I will be drawing on my experiences using Git and some examples from different companies. Okay, so the agenda for this presentation, I want to cover what has been said already and cover something called the single instance and the multiple instance approach. So before I started researching this project, I was aware of lots of blogs and videos being available regarding this subject. So I'm going to draw these together and present in a diagrammatic form what these opinions are. I'll also be covering something called parallel development. So this is working with multiple projects going on at the same time or staged one after another, whilst fixing live fixes as well. Okay, and then I'll cover working with workspaces. So workspaces are key to your project development. So I'll show you the best way that we found of creating workspaces. We're covering applications, including application offsets, and also including different ways of backing up and importing your application. Once that's done, I want to spend a little bit of time covering a document which was published by Oracle, Oracle white paper, called the Oracle Lifecycle document. So there's lots of good stuff in that, and I will break that down again into these diagrammatic pictorial views. And then we'll end the presentation with a brief overview of Oracle Cloud and Continual Integration and how that can help and benefit your development teams, including a bit about automated testing. Okay, so where to start? So a good place to start is here. So this is the Apex blog by Jules Kalman, who is the Director of Software Development at Oracle. And early this year, he put a blog out, and it's called Apex Development and Multiple Development Branches. So what he's saying in this blog is, from time to time, the same conversation comes up within development teams, and that question is, how can you manage the development lifecycle with lots of different projects, with live fixes going on at the same time, many developers? So how do you orchestrate this all together? So what he's saying is that the question was posed, and Cohen Lustra of the Oracle Curriculum Development Team posted a reply, and this really took Jules' attention, and he wrote this blog about it. So what did Jules' blog say? Well, a quote from Cohen Lustra says, development flow should be adapted to Apex rather than trying to use an existing process and apply that for Apex. Now this comes down to the nature of Oracle Apex. When you save your application, you're not saving into a file, you're saving into database tables. So as you change a setting on Apex, you're changing underlying data dictionary data. So you're not creating a file, you're not editing a file or deleting a file, which version control can really get its hands on and understand what your changes are. So you need to adapt your process to Apex rather than Apex to that process. So what did he actually say? Well, Cohen says that this is how he works in his team. So he has multiple developers. I'm illustrating 4 developers there. They're working on one or more apps, and these apps are in development. So he has an environment called development, which he calls the master. So that's the master set of the applications. He says that some developers may want to create applications locally or test things locally or in different environments or workspaces. And ultimately, when those changes are ready for the applications, he will export those pages or those components or copy them manually into the main applications. So for version control, he uses Oracle Developer Cloud Services, ODCS. And now ODCS has got a facility to have version control. You can choose between, I think it's SVN or Git. I'm not quite sure about that. There's a wiki on there. There's Hudson for builds. There's a place for managing projects and tasks. So he uses Git, and locally the developers use SourceTree as their Git client. Quite interestingly, he says there's no branching. So there's no branching for different projects. He just works in master. So master is where all the changes are reviewed. He can demonstrate changes to ultimately his customers. If they were to approve those changes, then they move forward into the build and stage environment. So stage is used exclusively for testing. Any changes which reach testing or reach staging will not be rolled back. So they've gone past that review point there. They use build options for hot fixes. So a build option, if you're unfamiliar with that, is just a switch. So it's either on or off. Should your new components be enabled in your application or disabled in your application? We'll cover this in more detail later on. And there's also a switch for whether you want to include or exclude that component at time of export. Okay. So Cohen uses agile principles where he's on a 3-week development cycle. So changes move from development all the way through build stage into production every 3 weeks. So I quite like the simplicity of this approach. It's a nice and simple approach. Okay, so I'm going to cover a few more examples of different clients that Explorer encountered, and a few more blogs we'll throw in as well. So, Explorer Client 1. So, Explorer have been working for this client for some time. They have their own development team. Explorer assist that development team and provide developer resource. Although the setup is quite impressive. So, they have, similar to Cohen's example, they have multiple developers working in one environment. They call it master as well. So, it's a master set of their application code. So they're working on several applications. Again, changes are reviewed in that environment before they make it into the testing phase. Now, these applications consist of many pages, and there's many packages and underlying functionality. Now, each developer has their own area of speciality, so they don't really conflict with other people's work, although the conflicts can happen. They have a heavy use of build options to control releases. So again, that switch to hold back code and components from future releases. They use Git as their version control. Now, instead of using something like GitHub or Bitbucket or something like that, they use Microsoft. So they use Microsoft Team Services. And again, Microsoft Team Services, very similar to ODCS, where it provides areas for tasks to be added. There's a wiki, there's a continual integration, and there's a build option there. Okay, so nightly they have exports of their applications and they instantly deploy it into their build environment. And now they have a CI agent called Team City, although they're also using the facility within Microsoft there. Now, Team City orchestrates and coordinates all the tasks that happen in the night. So one of the first things that happen is the virtual machine for build gets rolled back, gets reverted back to the last release. So they're working with 3-week release cycles. So say we're on week 2, the virtual machine gets reset back to day 0 of this 3-week release cycle, and then the code is automatically deployed out of Git onto that environment. So they have set scripts to deploy all changes. So it might be DDL scripts, or it might be DML scripts, new packages, or updates to existing functions and procedures. So that's deployed in the night, and then they have automated testing, which happens in the night, and the testing results are examined by the Continual Integration server and then emailed back to the developers. So we've got more on this automated testing coming up. They also use manual testing as well. They have a dedicated tester. So they also have this approval system for production, so that all the heads of departments can review a release, see the test evidence, give their thumbs up, which will authorize a test to release to production. Okay, so let's explore client 1. This is another blog. So whilst researching the subject of group working with multiple developers, you don't go far without seeing this blog. So this blog is actually a white paper by Rob van Wyk, and it's several pages. This application. It covers about 5 or 6 pages. It's very complicated. They've got a very complicated setup, and what I call this is the multiple instance approach. Okay, so rather than you reading it, I'll break it down into its component parts. So what did Rob say? So Rob says that each developer will work on their own environment. So they have their own database schema, their own Apex installation, they have their own workspace. In this example, it's rwyk_ws for workspace. Similarly, they have another developer here, AA, who is on their own environment, their own username, and now this user has their own schemas. They actually have multiple schemas for this workspace, and they have multiple apps. So the same apps are replicated, the whole environment is replicated through a series of complicated scripts. So they're using SVN as their version control, and for the client they use Tortoise SVN, Explorer have actually used this before, or Cornerstone. And they use no branching as well. Now they're in SVN, the directory structure looks like this. So they have non-Apex and they have Apex. So Apex has the application, which is exported and then split. So there's a Java application called Apex Splitter, which will split an export file into its component parts. So pages, shared components, lists, everything is split into different files. In the non-Apex, they have all the schema objects, so the package specs and headers. They have any supporting files such as image and CSS. They have installation and other scripts in an install folder. So how does this work? So in the night or daily, on manual request, each developer can decide to do an SVN update. So an SVN update gets the database objects, so packages, functions, procedures, sequences, etc. So those objects are taken into the workspace, and then they have a script to bring their database up to date. They also have something called Apex update.sh, which is a script which exports their application, splits it into a version control system, and they've got this offset system as well. So the offsets are, each component has a different ID, and those IDs are saved in your workspace. So when you import it into another workspace, what you don't want to happen is those IDs to clash with existing IDs within the application. So the worst thing that could happen was your application which you're importing could get corrupted, or the application that you're importing to could get corrupted. So they've got these offsets for each developer, and they have 10 billion difference between these offsets. So you'd have to create over 10 billion different components to clash with another developer's offset. They also use offsets to avoid version control detecting a change when there's been no real change. So this adds new files, deletes new files, it merges, and then it can reinstall Apex application to your environment. Each developer can actually set this overnight, so it refreshes their environment, although they may lose any interim work. So in the night, also they have Hudson, which coordinates the build of the Apex deployment, so they can build, test, they can build any other environment they want, and they can also use this to deploy to production. So it's a very interesting example. This quite complicated to set up. I don't know if I would advise this. How do Explorer work? So Explorer, this is the Git structure. So this is similar. We have source, and then we have Apex, and then we have our applications in here. This one's highlighted. We can put theme and workspaces. We like to export our workspaces. More on that coming up. In the database folder, we have our different schemas, one called commons, one called CRDB, and then we have package bodies and specs, one that's folders for each of the different schemas, commons and CRDB, different scripts, tables, views and triggers. Any other objects which we haven't got, so procedures, well, we don't have a folder for that yet, but we will create a folder for procedures should we have that need. Outside of source, we have other folders called data model, for example, and we also have the Git folder. So the reason for having data model as a sibling folder to source is that once a release is ready, we can just zip up source and send it to a customer with the release instructions. So we wouldn't want to be giving them the data model, for example. Now here's an example of a project we're working on. We Explorer are working within master, and we can see there's two developers working on this project. So there's myself here, and if I click on a commit, I can see that I was working on multiple email attachments. We've got a developer in green here who was working on different items, and we also have this user called Riga, which is performing nightly exports of Apex applications. So you just tell it what applications you want to export, and it exports them in the night. So you can see around 11 o'clock you've got these exports. You'll also see that on some days, for example the 19th of the 11th, and maybe the 19th of 11th, you can see that nothing was exported that day. It's because we've configured Git to only commit into Git if there's an actual physical change that happened. Now each time you export an Apex application, it comes with a date and timestamp of when you exported. So we have a little command in Git just to remove that date and timestamp, so it looks like there was no change to that application. Okay, so parallel development. So what's parallel development? Well, Jeff Kemp on his blog provides a good example. So he's working with this big custom bespoke application. They've got two projects, Project A and Project B, and the project management team don't know which project is going to release first. Meanwhile, they need to provide live support in coming up with new hot fixes for the live environment. So they had a big headache in how to manage all this at the same time. So what his blog says is that, let's say for example, the current on version 1, they decided to release Project A first and then Project B. So they had a meeting and they came up with this approach. So that solves it for project releases, but how will they be able to support live fixes? So what they came up with is they took a copy of this environment and called it the copy environment. So this copy environment is just used for live support. So any fixes which go into this environment will also, they have an agreement with the developer that they will put them into the latest copy of the application development environment. So let's call these 1.x releases, where they're coming up with live fix releases and they're being copied into the development environment. So when the time comes to release Project A is released, and then Project B. So here are the releases. We've got the live fixes, we'll call it 1.x, and then we have test Project A, which includes all the 1.x fixes, and Project B has been optionally excluded due to build options. And we have this thing called database conditional compilation for database objects. So this is an example of conditional compilation. We can have this condition: if project B, then install this package, else it must be project A, then install this project. So when project B comes along for its release day, it includes all the 1.x fixes and includes project A. And when this piece of code is compiled, it will install this version of the code. So this is pretty good, so that we can control the conditional compilation through a flag. But wouldn't it be better if we could use the build option flag instead of another flag that we had? So Martin D'Souza, with his blog, this is just over 4 years ago now, he came up with this function which detects the build option status. So you could easily use that compilation to pick the right version of the procedure to install. So I thought that's quite interesting. The next slide, Explorer Client 2, they had a similar problem. So they have multiple versions of the code. Say they're on version 5 now in development, that's current live version, and they're working on version 6. Now each time they release a version to the clients, those clients don't necessarily install that latest version, because they've got to fit into their test cycles, they've got to test lots of the code, it might be a bad time of year, whatever. So client 1 is on version 3, client 2 is on version 5 on the latest edition, client 3 is on version 4, and client 4 is on version 2, has not been updated for quite a while. So what happens if client 4 has a bug? So they require a fix in version like a version 2.1. So if you put the fix into version 6 and send them version 6, they won't release, because they would have to commit to all the testing in version 3, 4, 5 and 6 as well as their bug fix. So what's this client, Explorer Client 2, came up with is, again, this is parallel working. I'll show you how they came up with. So they've come up with two options. They can either copy this environment into different workspaces. So they've got a workspace for each client. So what they could do is, in the workspace client 4, they've got a copy of the app. They can fix it as version 2.1 and copy that fix into version 6. So that's the agreement they have. If you're going to have this separate workspace approach, then each application here needs a separate ID. And a separate application alias. Or, as Oracle advise, you can have different environments instead. It's probably a better approach. So let's talk about setting up workspaces, or setting up workspaces the right way. So you really want to make this as easy as possible, from the movement of your application from development to test, the easiest way possible. So how many workspaces do you need? Well, Oracle say different workspaces may be defined for different departments or functional groups within an organization. Okay, so that works well for Oracle. Oracle have got hundreds of departments and they've got hundreds of workspaces, each containing multiple applications in the workspaces for all the various teams and offices that Oracle have throughout the world. So that works well for Oracle, although we have many customers who are just a handful of employees. They don't have these multiple departments. So how about one workspace? One workspace is a good choice. If you're going to use more than one workspace, think about this. So if you want to copy and subscribe from a master application, so you could have a master application with a theme, list of values, different templates, and you want to maintain that in one master application and then publish changes for those components down into subscribing applications. If you want that copy and subscribe, then your master application has got to be in the same workspace. So if you think of the multiple workspaces example, you couldn't have one master application and then all those workspace applications subscribing to that. If you want shared cookie authentication to give multiple applications a feel of one application where you can log in once and then seamlessly navigate between all your applications, if you want that to work, it doesn't work when all those applications are in different workspaces. And if you want to have application groups and put those applications into a group, again, the same thing. So what is the significance of Workspace IDs? So here you'll see an export file. I've exported an application and it's got my Workspace ID like hard coded into the file. Well, what's the significance? Well, it's not real any biggie, but it does depend on how you want to import the export file. So it could cause a problem. Depends on how you import the file. So there's two ways of importing. There's Apex itself, where you use the import button, and there's SQL CL or SQL Plus. So SQL CL being the successor to SQL Plus. So if you use the import button, then you can import any application with any ID hard-coded into it. So we'll see the application ID 1919 there. You can import from any Workspace ID. You can import to your current schema. It doesn't matter what the schema, the original application came from. However, it doesn't replace any read-only applications. So if your application is read-only, which it should be for any non-development environments, then it won't replace any of those. So this is how we can share applications across the internet. I can export an application I'm working on, I can give it to you, it will import into your environment if you use the import button. Now if you use the SQL CL or SQL Plus, then when you run the file at F1919 in this example, it will want to install into that workspace into overwriting this application using that schema. So if it can't find those three things, it won't install. However, you can get it to work if you use the Apex install app package, which came with I think some of the early versions of Apex. So you can, before you install the application, you can set the application ID, Workspace ID, and schema, and it replaces read-only applications as well. So here's an example of this working. I'm ultimately going to install this application here. Before I do that, I'm going to set the Workspace ID to, well, I'm just going to fetch the Workspace ID where the workspace is called ADV, and then I've got my Workspace ID. I'm going to generate an offset so I don't clash with any offsets with any component IDs which I currently have in my destination environment. And then I'm going to set the schema. Well, this application came from a different schema. I want to say use this schema ADV. I install it and it works. Here's my application. Now this is green and pink because at the time I was testing exports on themes. So I just want to prove that's working. Right, more on application install. This is from Joel Cameron's blog. Now he's using the same thing I'm using, although he's using generate application ID. So rather than overwrite the ID, the application ID in the file, he's specifying a new one, and he's also setting the application alias here. It's based on the application ID. If you want to avoid Apex application install, then export your workspace. So when I have a new project and I'm on development, I create a new workspace to put my applications in. As soon as I create it, I export it. I export it in a file and I put it in version control. The default export type is minimal, so you don't get any logs or user preference, save SQL, none of that. So I export it and then I import it onto test and production. That way all my IDs are aligned and therefore I have no issues when I'm importing applications because the file contains the same ID. It's the same. I use the same schema. My applications will overwrite, so works really well. There's another way to avoid Apex application install. On SQL-CL, it runs JavaScript in there, so if we use this script called apximp, and if you type apximp, it comes up with all the settings. So an example right down at the bottom, we're going to import file 102 with a specific offset of 123. We use a name, which is the name of the application, the alias, and we can change various things as we install the application. We can install supporting objects as well. So if you edit this file, if you view what it does, it's actually using Apex application install. It's just building up a PL SQL file just to run it before you import the application. So it's quite clever. You can do everything in one line, which I do like. So it just makes that as easy as possible. So that's importing. With exporting, you're familiar with the Apex export. There's various options here. I'll just draw your attention to export the supporting object definitions, export with original IDs, and the build status. So we've got run and build application. So I'll refer back to these later in the presentation. Second way of exporting application, you can use Apex Export. Now, Apex Export is a Java application which comes with your installation of Apex. So when you download it from OTN, that file is present, and it also comes with Apex Splitter, which splits the export file into the various components. So if you want this to work, you need to be in a very specific folder. You need to be in the Apex Utilities folder. You need to set your Java class paths up, and there's quite a number of blogs on how to help set that up. You give it a database name, a user, a password, and the application you want to export, or you give it a Workspace ID, and all the applications are exported. So when I run that Java application, I can see it's exporting application 110, and when I list the folder, I can see I've got 110 in there. So it's a very handy way of exporting an application, and it's pretty good for automating it. So when it talks about nightlies or automated install or builds, it's very good. Or you can use SQL for exporting an application. Now if you just type Apex, it lists all the applications associated with the workspace which the schema you're logged into is associated with. So you can see all applications here. I've got several applications in this workspace. Apex, it lists the Apex commands. So Apex lists all the applications which I've just done. Or Apex Export, application ID exports the application which could be combined with a spool for writing to a file. Let's try it. So Apex Export, so we'll put Spool on. Spool to this folder, this file, Apex Export, application 365. And then we've got spool of thousands of lines of code. We get right down to the bottom, we're going to say spool off. We can open the file, and then we've got a file, an export file ready to import. Pretty good way. Or you can use Apex Application Archive. So this is a package application. It's the first one when you click on package applications, and it allows you to back up applications into Apex itself. You can review your applications you've exported, and you can then import them back into the repository and then install your Apex application from there. So a few quick facts that I came up with while investigating this area. The documentation is not quite clear which folder to use when using, for example, Apex Export to import-export your applications. Well, these seem to work. So your parsing schema seems to work, which may be the most convenient because you know the password, or the Apex 050,000. So this is set up when you install Apex. The installation file script uses a random password and it locks the account. You can unlock it and change the password. You can export that way, or you can use sys if you've got access. You can, for Apex Export, you need to find the right version of Apex Export for your Java application. So using Apex Export version 5 to export 4.2 apps doesn't work. There's no option to export developer comments. So when I exported applications through the front end Apex itself and through Apex Export, I saw a file size difference, and I looked at the differences using a compare tool, and all my developer comments were there. So you must be aware about that. There's many export options I'm missing from there. You don't get the amount of options you get when you're exporting through Apex front end. Okay, so that's Apex importing, exporting done. So let's cover the white paper. So the white paper came out this year. Explorer were asked to review it. So I and my teammates reviewed this paper, and we submitted our feedback to the author, and revisions were made, and the paper was published. So this is called Lifecycle Management with Application Express. So I advise you to read the paper, but what I'm going to do now is I'm going to break the chapters down into bullet points or diagrammatic forms to illustrate what the content is. Okay, so it starts off saying all of the good stuff that we've known for many years. So externalize your code, have everything in PL/SQL, put it all as packages, follow best practices in terms of projects, management of projects, database design, standards, security testing procedures. We know all this stuff. But they also say for in-house development, Oracle does not recommend utilizing supporting objects. So these are designed for packaged applications and commercial applications. So supporting objects allows you to put messages in there, set prerequisites. You can install files such as table creation scripts and data files. You can have upgrade scripts. You can have removal scripts. So it says does not recommend. Interesting. They're saying use separate environments for each environment. So for development, build, stage, and production, separate environments, or you can just pluggable databases in 12c. They say always export from development, always release from source control. So this is good advice. I won't disagree with this. For secure environments, database administrators should be the only ones with permission to access and update the test or production environments. Again, I don't disagree. They say you can remove items like SQL Workshop from non-development environments, and you can also set the build status for run application only, which removes the edit facility to edit the application in a non-development environment. And in 5.1 there's a new feature to set the application status via SQL, so that's pretty good. For releases, they say release your application, all the DML and DDL and others, for example JavaScript and images, in one release file. Call it release.sql or release.sh, like a batch script to run. And when I say no more downtime, the white paper says that you can release an Apex application while users are still using the system. So it sounds a bit scary to me, but that's what they're saying. They're saying that it can be released without any errors or downtime in the application. They have a section on bugs. So this is a lengthy section on bugs. I think I could break this down into a flowchart. So they're saying, can the bug wait? It can wait, so let's put it in the next release. If it can't wait, well, is it occurring right now as we're releasing the application in a big release? If it is, then fix it on production. Sounds scary again. Fix on production, and then importantly, step number 2, reapply that into development. So new releases will include that include that fix. So if it's not occurring mid-release, does it impact existing development that's happening on your environment? If it does not, fix on development and export those component changes. So export perhaps the page from development and import that page into production. If it does impact existing development, well, are build options feasible? Can we build option the existing developments and just put this new fix in? If it is, then we're going to apply a build option to exclude the existing development. We're going to fix it on development, and then we'll export the whole application and replace that in production. That would work. If build option is not feasible, so if you've done so much work you just can't work out which build option is to be put on, or if you could, you need testing on that, so they're not feasible, then we'll export production and import it into development as a new app ID. We'll fix it on development under that new app ID, and then we'll use the export under original IDs, which I pointed out earlier. If you export with the original IDs, it uses the same component IDs, so it will match the same component IDs when you import the application. So once you've exported it and imported it into production, you need to reintroduce that fix into the original app, development app ID, and then perhaps delete the production application you've just imported. A slide on build options. So here's what a build option looks like. You can see which application it refers to. You can see the build option name. This one's called Phase 3. The status is exclude, and the default on export is same as current status, so basically exclude in this example. So the status includes excludes from the current application. So if I had a component and assigned it phase 3 and ran the Apex page, I wouldn't see that component because it's exclude. The default and export, well, basically that component with that build option is in the exported file. When you import it, it does exist on that page. It has the build option assigned to it, but if that build option was an include, it would, and this was exclude, it would now set it to exclude. If you're not sure what build options you want at time of defining the build option, then you can specify a prompt. So in supporting objects, as long as you export with supporting objects, you can set which build options you want to prompt when you install the application, and then the release controller or the DBA can specify which build option. Top tip: when you finish with build options, when you've released your application with a build option and everyone's happy with the release, delete your build options. Just delete your build options. Your components will still be there, but they won't be assigned that build option. Next, the Oracle white paper says managing Apex applications. So they say one application should be approximately 50 pages. If it's more than 50 pages, consider multiple applications. Sounds fair to me. Use a master application and use subscriptions. So you subscribe your theme, your authentication scheme, the authorizations, list of values, etc. Use team development. Now they're saying this is a unique feature for Apex where features, to-dos and bugs can be associated with pages. So when you associate it with a page and you visit that page, you get a red ticket in the top right hand corner. You can drop that down. I can see there's one bug, so there's one bug for me to fix there. When on pages with multiple developers, you've got your choice. You've got your choice of page locks. So here I lock a page for myself, it goes green. Or someone else has locked a page, I try to enter this page, it goes red. If that person's left the business or gone on holiday for a long time, a Workspace administrator can unlock that lock. So your choice of page locks, or why not multiple developers on the same page at the same time. Apex does support this. However, if you were to change the same component, if multiple developers were to change the same component and press save, you will see this error message. There's a chapter on developer skill sets. So they advise a basic and advanced developer. So the advanced developer has some JavaScript experience to complement their PL SQL experience, and they would have some design standards. They suggest a UI developer who can work with HTML, CSS, the whole user interface, the whole look and feel, and if necessary, an integrations developer who can work with web services, REST, security, JSON, XML, for example. The database architects administrator skill set would include design standards, but also the primary focus would be security, database design, performance, configuration, all the good stuff that DBAs do. Lost application development. So if you lose an application, you can export as of using the flashback queries and re-import your application. You would lose any interim development you've done, but it's a possibility. You can restore your Apex application from backup. We use Nightlist, so we've got nothing lost there. We could restore the whole database from backup. So you restore the whole database, your application is restored as well. If you need to reinstall Apex for any time, get it from OTM. So that concludes the Lifecycle management paper from Oracle. It's up to version 2 now, with the latest release being in September. Oracle Cloud Developer Service. So with Oracle Cloud Developer Service, you can use this tool to manage your source control. You've got Git repositories there. You can integrate existing repositories into GitHub, which is pretty interesting. You can use issue tracking, so for bugs, defects, features, to-dos, You have all that in issue tracking. You've got continuous integration. So you've got Maven and Hudson there, so you can integrate scalable build and test environments. And you've got a wiki there as well. And Developer Cloud Service, or DVCS, is technology agnostic, so it supports all development technologies, not just Oracle ones. It also goes hand in hand with the cloud database as well, where you can provision environments on there. So there's a link to a YouTube video if you want to write that down. So it's bit.ly devcs_apex. Now this is a presentation by Jules of Oracle, and it's well worth watching. It's about 17 minutes long. Now the whole presentation is about the automatic or manual provision of a cloud database for a build to test builds on, basically. So step one, a developer would work with their environment, their development environment. They would maybe change some database objects, maybe change the Apex application. Once they're happy with those, they would save it into local Git repository and commit that. So into Git here, those changes are committed locally, and then they can be pushed to DevCS, so the Git server on DevCS. So in Oracle Cloud Developer Services, you could review that. So you can review all of the commits. You can see that a developer has pushed in a new commit. Now, the clever stuff. So you have build jobs on that. So these could be triggered manually or automated. So in this presentation, he's got Jules has a trigger on the f100.sql export file. So when Git sees a new version of that, then run this job, and the job creates a new schema, a new object, and a new environment, a new cloud database environment. So everything is set up, taken from Git using the install scripts. It installs all the objects, installs the Apex application, and then it's ready. It's ready for running test. And in his example, he proves that exact same thing. So once you've got the your Apex in the build environment or your staging or test environment, you want to do some testing on that. So for PL/SQL, there's Del Code Tester, there's UT/PL/SQL, SQL Developer's got some unit testing in there. There's lots of frameworks available. But what's available for Apex testing? Well, this is the answer. The automated the Apex Test Automation Framework, or ATAF, which is a acronym for Apex Test Automation Framework. So if you use the URL there, you've got apextestautomation.co.uk. So what this is doing is you would import ATAF, which is an Apex application, into your workspace, and there's installation instructions how to install that and the different schemas that are required. You would create a project. You would create a test specification. So in the example I'm going to show you, it's going to be make an order. You would use test cases for that, such as log in, find the orders tab and click it, fill out the details, hit the submit button. So different test cases for that. So each time you save a test case or specification, or indeed a project, you're saving it to the Apex views. You would specify an application you want to test, and then it would bring back from the Apex views and the data dictionary which items you want to test. So if you want to test page 3, for example, it would know from the data dictionary which items are on page 3. So you would say, drop down, I want to test the radio button, and you want to specify these values. So when you've created your test environment, your test project, you'd hit the export button, and it would create a script for running in Selenium. Now Selenium is an add-on to Firefox, which allows to process scripts run in Celanese, and this is what ATAF exports into. So following the scripting language in Celanese, you can see Firefox logging in, clicking the order button, creating an order, pressing the place order button. If it finds any faults in that process, it will report it back. It'll save it into a log file. Your continuous integration server, TeamCity for example, can spot something in the file and then email back to the developer to say that build has failed. So here's ATAF in action. We're creating a project. We're actually testing the sample database application. So here's the first test case. We're going to click the orders in the list. We're going to click the button Enter New Order. We expect modal dialog to be shown, which is page 11. On page 11, we're going to click a radio button, create order for, and then we're going to choose something from the select list. So here is our test for test 1. So from page 1, we're going to click the list item, and then we can drop down navigation sidebar option, and we're going to click the orders item within there. We expect to branch to page 4. So what you usually do is you get your Apex application in one monitor, one side of the screen, ATAF in the other side of the screen. You're going to click on the sidebar option, orders, and then you're going to fill out this page here. So here's an example running Celanese in Selenium. We've created an ATAF project. We've exported into Celanese. We've said what application page we're going to open up. We're going to log in with demo, username and password. It's so good, so far so good. It's logging in. We're going to use the logout button, and something's failed here. So something will fail. You write into the log file, and then you would export it and that file, and you would email back to the developers. So with ATAF, you've got some additional benefits. You've got some testable different development. So you could go right up to the specification level and you say create orders. So a developer would create orders then, several pages to create those different orders and different validations, different processes. So once the developer's done, then you could write those test cases, exactly what you need to do to test it. You can also do some load testing as well. So what's pretty good about ATAF is in future releases, you can test simultaneously different browsers, different environments. So you've got test of your Mac, you've got test of Windows, other operating systems, different browsers. So you've got IE, Firefox, you've got Chrome, and you can test these simultaneously. You can also use ATAF to bulk load data as well. So if you wanted up to 3,000 records, you can set ATAF running 3,000 times, entering different person data. You can also give CSVs to users in a specific format, and the user could fill out what test data they want to run, and you could import that into ATAF, export it as a Celanese script, and you could run through users' test data. So definitely advised. When you think about Selenium as well for automating browser clicks, multiple browsers we've covered. What else you could do? You could run the Apex Advisor, which tests for security and programming mistakes. It could automate some security tools. Several are available, so there's lots of potential. So that's coming towards the end of the presentation. I just want to debrief about the different blogs we've looked at, single and multiple instance approaches. We've looked at working with workspaces. We've looked at application install with your offsets to import different applications through the command line, different ways of backing up and importing. We've looked at the Oracle Lifecycle document in detail, and then we've finished with the cloud and continual integration with ATAF there. Okay, so I'll leave you on the final slide. This is our website, explorer-development.uk.com. It has all our latest blogs up there. If you click on the blog element there, we come up with a blog at least every month. I'll leave you with my email address at the bottom. So thank you for watching this presentation.